We have already solved systems of equations by graphing and by substitution. Today we are going to solve systems of equations by elimination. Now, just like substitution reflected its name, substituting, elimination is going to do the same thing. We are actually going to eliminate a variable. We usually use elimination whenever our two equations are in standard form, like this example here. Here I have x plus 5y equals 9, and I have 4x minus 5y equals negative 14. So I want to eliminate a variable, and what I mean by that is I want to actually add my equations together, and one of them should cancel out to 0. So on this first example, x plus 4x gives me 5x, and 5y plus negative 5y cancels out to give me 0. So this would actually be 5x equals 9 plus negative 14, which gives me negative 5. Now, when you do this, it's really important that you have the same coefficient to eliminate, and one of them has to be positive and one of them needs to be negative. If you add your x's together to get 5x, you have to add your y's, but you also have to add what's on the other side of the equal to sign, or it won't work. Now, all I have to do is solve for x, so I'm just going to divide both sides by 5, and I know that x equals negative 1, because negative 5 divided by 5 gives me negative 1. So I have my first part of the equation. My first part of my answer is that x is negative 1. The second step is to solve for y. So you could plug it in negative 1 to either equation. I'm just going to plug it into the first one. X plus 5y equals 9, and I know that my x is negative 1. So I'm going to rewrite this as negative 1 plus 5y equals 9. Now all I have to do is solve for y. I'm going to add my 1 over. 5y is 10. Divide both sides by 5. And y is 2. So now I have my answer. Negative 1, 2. Now you can check these just like with substitution. I'm going to actually check by plugging it in to the second equation, since I used the first equation here. To check, you should be able to plug it into both equations to make sure it works. So for 4x minus 5y equals negative 14, I have 4 times negative 1 minus 5 times 2 equals negative 14. Negative 4 minus 10 does equal negative 14, so we know we did it correctly. Now sometimes when you use elimination, you have the same coefficient, but they're both positive. So what I'm going to show you on this one is we are going to actually subtract our equations. I like to think of it as just multiplying the whole second equation by negative 1. In order to subtract these, I'm going to change the signs on all three. If I change this to negative 3, then I'm going to change this to negative 2 and this to negative 26. The reason I do this is because 3 plus negative 3 is going to give me 0. And since I want to eliminate my x's here, I'm going to make one of them negative. I could have done this to the top equation, but I'm just going to do it to the second one. So now when I add these together, 3 and negative 3 are going to eliminate. I have negative 4y plus negative 2y, which gives me negative 6y. And 2 plus negative 26 is negative 24. Now, it's also very important to make sure that your variables are lined up with each other before you even start this, and that your equal to sign is lined up as well. Now I can solve for y. I'm going to divide both sides by negative 6, and we have y equals 4. So we have our y value. Make sure you write it as your y, not your x. And now we're just going to plug this into the first equation. I'm going to plug in 4 for my y, so now I can solve for x. I have 3x minus 4 times 4 equals 2. So 3x minus 16 is 2. Add the 16 over. 3x equals 18. Divide by 3. And x is 6. So my answer here would be 6, 4. To check it, I'm just going to plug it into the other equation. It should work for both though. I have 3x plus 2y equals 26. I'm going to plug it into the original equation. So I'm plugging in 6 for x and 4 for y. We have 3 times 6 plus 2 times 4 equals 26. And 3 times 6 is 18. 2 times 4 is 8. And 18 plus 8 equals 26. So we know we did it correctly. Now sometimes you're going to see examples where the coefficients are not the same. So on this example, I have 3x minus 3y equals 21, and I have 8x plus 6y equals negative 14. The trick here is that I need to multiply one of my equations by a number in order to get the coefficients to be the same. I'm going to try to eliminate my y's here because I have a negative and a positive, and that just makes it easier because I need a negative and a positive to eliminate it. I also know that 3 times 2 gives me 6. So in order to have the same coefficient here for my y's, I'm going to multiply this whole top equation by 2. When I do this, I'm going to distribute the 2 to every term. So I'm going to rewrite my equation as 2 times 3x is 6x. 2 times negative 3y is negative 6y. And 2 times 21 is 42. You have to make sure you multiply it by every single term. Then I'm just going to rewrite my second equation. I have 8x plus 6y equals negative 14. Now I'm ready to eliminate this because negative 6y plus 6y will give me 0. If you need to go back and rewatch this step and how I found this, I would do so now. This step is very important. Now I can just add these together. I have 6x plus 8x is 14x. Negative 6y plus 6y is going to eliminate to 0. And then on this side, 42 minus 14 is going to give me 28. Now to solve for x, I'm just going to divide both sides by 14. And we know that x equals 2. So we have the first part of our answer, x is 2. Now to solve for the second part, I'm just going to plug this in to my first equation. I'm going to actually plug it into the original equation. So I am going to plug in 2 for x. We have 3 times 2 minus 3y equals 21. So 6 minus 3y equals 21. Subtract the 6 over. We have negative 3y is 15. Divide by negative 3. And y is negative 5. So here we have 2, negative 5. To check it, I'm just going to plug it in to the second equation. It should work for both. We have 8x plus 6y equals negative 14. So 8 times 2 plus 6 times negative 5 should give me negative 14. 8 times 2 is 16. 6 times negative 5 is negative 30. And 16 minus 30 is negative 14. So I know it works. And this is my answer. And that's it for elimination. So make sure you be careful what you're going to multiply by. If you need to rewatch this example, I would now. And make sure you always check your answers.